Hello, Algebra II students. This is Mr. Kraft coming to you from my house as usual. I want to make this one single video that will cover the last three sections that we've talked about, most of which are review. That will be easiest. So, go over here briefly. I want to start talking about inverse functions, given in terms of a relation, such as these first two, given in terms of how to find an inverse, and given in terms of verifying an inverse. So let me give an example. The first type of thing. It says 1, -3, 1, -3, -2, 3, 5, 1, and 6, 4. So given a function, how do you find the inverse? This equals function of x. What does a function mean? A function means you take a set of numbers, which we call the domain, the first numbers, and then you map them onto a second set of numbers, which we call the range. Or another way to put that would be to say you're saying x matches to y. So your inverse function, where you've got your inverse, you're just going back the other direction. That's all it means. So your inverse function just reverses everything. 3, 1, -3, 1 rather. 3, -2, 5, and 4, 6. So that's all. That's the only thing you're doing on that. No big deal. The second situation, you have something like y equals 3x plus 2. Find the inverse. So y equals 3x plus 2. We rewrite that function notation. Well, you don't have to really, but I'm going to go ahead and write it this way for reference. I'm going to use this form of it, though, to actually work on these things. So I'm going to say, replace my y with x, replace my x with y. Because remember a while ago, if we had like 2, 3 in this function, then I said your inverse is just 3, 2. You're going from x to y in this case, and in the opposite, you're going from y to x. So that's the only reason that we do this. I'm just replacing my y with an x and my x with a y to show that I'm going backwards. And then I flip it around. 3y plus 2 equals x. And then I solve for y. And that brings us back to SAM, which is simplify. I'm not going to write the whole thing out. Add, subtraction, and multiply, which includes division. So I get rid of the 2 on both sides. That gives me 3y equals x minus 2. Then I divide everything out by 3. Now, the way your textbook was doing this, it left it all as a single fraction. I would tend to break it up. The reason I would do that is because this is your standard mx plus b format of a linear equation, where the implicit 1/3 is your m, and -2/3 is your b. Either one of these is fine. And of course, once you've got that, You're just going to replace, whichever way you prefer to put it, that is inverse function, the negative 1 of x. That's all you're doing on these, that's all. Okay. So, the last situation here, it gave you two functions and said verify that they are inverse. And let's do 21 because it's more interesting. Fx equals negative 3x minus 9, negative 3x minus 9, and then g of x equals g of x equals negative 1/3 x minus 3. Negative 1/3 x minus 3. How do you know that these are in fact inverses? So basically I'm asking the question, is g of x the inverse of f? Well, let's think of a simple case. If I said 3 equals, well, I don't want to write it like this. 3 and negative 3 are additive inverses. Is that true or not? Well, I find out. I say 3 plus negative 3 cancels out. So, yes, they're additive inverses. And this is true for any kind of inverse you have. So if I said 3 and 1/3, are they multiplicative inverses? Well, I multiply them and see what happens. 3 over 1 times 1 over 3, everything cancels out. You get 1. Yes, they are inverses. So, essentially what you're doing is saying, will f of x and g of x cancel everything out so you come back with plain old x? Because see, to use the example here, if I had x plus 3 minus 3, they cancel out and I get just plain old x. If I had 3x times 1 over 3, 3's cancel out, I get x. But if I said x plus 3 minus 4, 3 minus 4 is negative 1. I don't get x alone. So 3 and 4 are not inverses. So what we have to do is first erase a bunch of stuff here. And that's the only thing I don't like to do on this, because the erasing seems to lag a little bit, although, to be honest, it's actually going faster today than it usually does. So I can't really complain. Okay. So basically what this boils down to once more is g of x, yes or no, equal to the inverse of function of x. In order to do that, I'm going to have to say f of g of x, which is exactly the same thing as f composed with g of x, which means substitute g into f. So I take all this stuff here and take it up there and plug it in and see what happens. Negative 3 times negative 1/3 x minus 3 minus 9. This here, as you all should know by now, is a distributive property. I get negative 3 times negative 1/3 x minus 3 times negative 3, because it multiplies with each thing inside, minus 9. Well, 3 and 3 cancel. Negative times a negative is a positive. So I get plain old x. Negative times a negative is a positive, and 3 times 3 is 9. And this negative 9 is left here. Plus 9 is 0, so I get x by itself. So ding, 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 this is true. Now, if I would have got anything else, if I would have got x plus 5 or x minus 7 or 2x or whatever, if it had been anything but just plain old x, then I would have said no, it is not, they're not inverses. But in this case, it turns out that they are. So that is the answer to that question. Okay, so this is how this kind of thing here is working. That pretty much covers that. Let's go to linear equations. Slope-intercept form of each line. We've done this before. I know it's been a while, but you should have had this in Algebra 1 as well, and it doesn't hurt to know how to do this. 3x minus 2y equals negative 16. 3x minus 2y equals negative 16. Well, the slope-intercept form is y equals mx plus b, where m is slope and b is y-intercept. So on a graph, that's a horrible graph. Y-intercept is where it touches the y-axis, and the slope is how steep it is. So basically, this is a very simple problem, people. You're just algebraically solving for y. And, if you don't get anything else out of this class from this whole year we've been together, if nothing else, I hope you remember SAM, because that's how you solve equations. Simplify, add, and multiply. So I want to get y by itself, so I have to subtract out the 3x first. So I get negative 3x plus 16. Now, normally I would stick the thing I'm adding or subtracting to the right, but in the format of the y-intercept, I want to have the mx first. So I drop that 3x down in front of the 16, and that 16 was negative. Wasn't paying attention there. So that should be 3x minus 16. One thing students screw up here is that this negative does not go away when I get rid of 3x. So now I have negative 2y equals negative 3x plus 16. I have to get rid of the 2. So there was no simplification. We did the addition, now we're to the multiplication. Divide everything by negative 2. Cancels out here. Y, negatives cancel, so I get 3/2 x, or you could write that 3x over 2. These mean the same thing, but 3/2 x looks better because you see the m number separately. And a negative divided by a negative is a positive. 16 divided by 2 is 8. That's your answer, people. You're not getting y equals a number or x equals a number. You are simply getting the equation format of this. That's all you're doing. So then it says standard form of the equation through the given point with the given slope, and the point slope form of the equation being described. Okay, so let me write one example. Let me see number 9. 1, 2, slope equals 7. So number 9 is 1, 2, slope equals 7. And then let's do 17, 4, 2, parallel to, what number was that? 17. 4, 2, parallel to y equals negative 3/4 x minus 5. Remember, fractions are your friends. In both of these cases, you are going to want to use the point slope formula, which is simply y minus y1 equals mx minus x1, where m is the slope and the x1 and the y1 are the. In this case, I'm going to say y minus, well, there's your y. How do you know? Second place. M, which is 7 times x minus x1. Bam, again, simplify, add, multiply. So I simplify 7x, 7 times x is x, 7 times negative 1 is negative 7. I add, I get the y by itself. Y equals 7x minus 5. And then you're done. That is all, people. I hope you remember this. We did these before. That's all we're doing. Here, if you remember, parallel lines, and the symbol for parallel looks like an 11, have same slope. So m equals negative 3/4. So back to point slope. Y minus 2 equals 4 times, I'm sorry, not 4, negative 3/4, that's my slope, times x minus 4. Well, y minus 2 equals negative 3/4 x, this times that. Negative times a negative is a positive, and the 4's cancel out, so I get plus 3. Then I just add 2 to each side. Y equals negative 3/4 x plus 5. And that is all they want there. That's your answer there. See if they've got a perpendicular one. Whoop. They're all parallel. So that makes it easy for you. Perpendicular, let me do one like that anyway. Suppose they said through 3, 4, perpendicular to y equals negative 1/2 x plus 6. Well, the slopes of perpendicular lines are inverse reciprocals. So my slope inverse, that means I change it from negative to positive. Reciprocal, instead of 1 over 2, I do 2 over 1. And then guess what? I go back to my point slope, which is the most widely used of these guys when you're doing these equations. So I'm going to say y minus 4. New slope is 2 times x minus 3. Simply multiply these out. 2 times -3 is -6. Add 4 to each side. Y equals 2x minus 2. That's how that works. There's not that much to it. Okay. Okay, so we talked about the inverse functions. We talked about the linear equations. Let's talk about the linear inequalities. And the ones on the first part work the same way as the ones on the second part, except the second part you're not graphing them. So one example of this should suffice for all. 5x plus 2 is less than or equal to 17. 5x plus 2 is less than or equal to 17. Well, for the third or fourth or fifth time, comes back to Sam. Simplify, add, which includes subtraction, and multiply, which includes division. And you do it just the same way as you would an equation. No simplification to be done. Do the addition. 5x is less than or equal to 15. Divide out. X is less than or equal to 3. 15 over 5 is 3. Now, if you divide, if I would have divided by a negative number, it flips the direction of the sign. You always have the x on the left. Then you have your number line, and you don't even have to put all the markings in, although the ones provided for you had that. 3. Well, remember, if it's greater than equal, less than equal, it takes a filled-in dot. If it's strictly less or strictly greater, it takes an open dot. In this case, it is less than or equal, so it takes a filled-in dot. Then the direction the inequality sign points is the same direction that the arrow goes, boom. It did not even ask you to write this in interval notation. You could say it comes up from negative infinity, because you always go left to right, to 3, and since infinity is never included, it takes a this. Since 3 is included, because of that or equal to sign, it takes a bracket. But it's not asking you to do that. That's how that works. I hope this clarifies these problems here, and I will talk to you later.